insert interval. So given these intervals, non-overlapping intervals, and we need to insert it. So when we are inserting it, we can see that with this one overlaps. So we are just updating our output with this, the starting of it and the last ending of it. So this range, because like when they merge together, we can see that it starts from 1, 8, and 5. And if we take a look at this example right here, given 4 and 8, and we can see that here, 3 of them, they overlap with this part. So in this case, we need to keep updating it and then so just have only one output for it, which will be just 3 and 10. So the way we're going to solve this, we will split it up into 3 different loops. First loop, we'll just add everything up until the overlapping part of it. The second loop will process the overlapping and have the only one updated new interval, and then the rest will just add whatever they left. So let's go and solve this problem. Integer result new array list, and like I was saying, we'll have 3 different loops, so it's better to create all these local variables in here, and which will be run until the length of the interval. So while I is smaller than n, and the first one is to add this part right here. So we can see that 1 and 2, the end part of the intervals smaller than the beginning part of the new interval, then we will add it. So intervals I, the end part is 1 smaller than new interval beginning part of it. Then we'll just add to our result. So add intervals I, and we'll just increment our I. Perfect. So the second loop, we will be processing our new interval. Will be, and then the way it will be running. So we can say that intervals I. So the beginning, the start, if it's smaller or equals to new interval ending of it, then we'll be updating our new interval. So new int, and it will have the first value will be math mean of the intervals I and 0 with new interval 0. The bigger part of it will be intervals I and 1 with new interval 1. Perfect. So if you take a look at this example right here, this is making sure that the ending of the, if ending of the intervals is still smaller than the start of the new intervals is still smaller than the ending of the new interval, then we'll be still trying to get the new interval because like it overlaps, because the end goal, when it doesn't overlap, the intervals starting, which is like, let's say is right here 12 and 16, the 12 should be bigger than the ending of the previous previous interval. So that's what we're trying to make sure. So if it's still smaller, so in this case 12 with 10, you can see it's bigger, but if it's still smaller, that means like we need to get our new interval. And once we have it, we can just add to our result. So this is new interval, because like we are keep updating our new interval. Like if we take a look at this example, 3 and 5 with 4 and 8, it becomes 3 and 8 in this one new interval. And then we are moving on to 6 and 7, and we still have 3 and 8, which is 8. The end part is still bigger than the starting point. That means it overlaps. Then we are updating it again, etc. So we keep doing that. So while the last part is when it's just smaller than, like, whatever is left out, we'll just add it. So resolve add intervals I and increment ri. Perfect. And lastly, we will just return our result to array new int result size. Perfect. Let's run our code. Time exceeded. Why is that? So, here we need to increment our time, increment our index, because it didn't exit out our second loop. Perfect. So time complexity in here, we see that there are 3 loops, but they're just going and seeing this interval one by one. So it is O of n, where n is the length of the intervals, and being just 3 doesn't really matter, because like 3 times n is just n. So overall time complexity O of n, and space complexity, we're not taking into account this output result. So we're just using some temporary values in here. So by the runtime, our space doesn't grow, so it's O of 1. It's constant.